Okay, so now we're going to look at derivatives with parametric equations. So we want to understand parametric equations and understand the calculus applications with parametric equations. This, again, I'm not trying to make it sound easy, but we've done enough derivatives that this should hopefully be pretty straightforward. So some helpful things when we're thinking about plotting parametric equations, it would be to know where maximums and minimums occur. And because we have an equation for the x coordinates and an equation for the y coordinates, we can find maximums and minimums of x, and we can find maximums and minimums of y, and we can find maximums and minimums with y with respect to x. So those are things that can help us out. So I want you to find dx dt, dy dt, and dy dx in terms of t. So I want you to do this, pause the video, unpause when you're ready to check. All right, so dx dt, derivative of the x function with respect to t. So that's going to be 2t, power rule, boom. dy dt, derivative of the y function with respect to t. That's going to be 2. All right, dy dx, there's going to be two different ways in which we can find this. One, it should hopefully make sense that dy dx can come from dy dt divided by dx dt. So if I take 2 divided by 2t, I get 1 over t. So dy dx in terms of t is 1 over t. Or how else could I do this? Well, I could convert the parametric equations into rectangular equations and then take the derivative. So if I say t equals y over 2, so I'm isolating here, and then I substitute that into the x equation, I get x equals the quantity y over 2 squared plus 1. Simplify that a little bit, x equals y squared over 4 plus 1. Take the derivative of both sides of that equation with respect to x now, because now I have an equation of y and x, so the derivative of x with respect to x is 1. The derivative of y squared over 4 with respect to x is y over 2 dy dx, and the derivative of 1 with respect to x is 0. Now isolate the dy dx, and I get dy dx equals 2 over y. But I know y was 2t. So in terms of t, dy dx is 1 over t. So again, it's just showing us that there are many ways, or multiple ways, I should say. It's not like there's a ton in this case, but there's multiple ways in which we can find dy dx from a set of parametric equations. We can use dx dt and dy dt, or we can convert to a rectangular equation and take the derivative with respect to x. Next one. Again, I want you to try this on your own. Where are the maximums and minimums for each variable? Over what interval is x decreasing? And over what interval is x increasing? And I want you to justify that. What does justify mean? Derivative speak, our favorite. And over what interval is y decreasing and increasing? And again, justify that. So what we're doing this for is for the last set of parametric equations. So we're still using those same set of parametric equations. Pause the video, find all of this, unpause when you're ready to check. Okay, so the first one, where are the maximums and the minimums for each variable? Well, I know dx dt is 2t, so my critical value is going to be when t equals 0. So I can make a chart with 0, plug in -1, plug in +1. I see I go from negative to positive. So since x prime of t is less than 0 on -5 to 0, and x prime of t is greater than 0 on 0 to 5, at t equals 0 is a relative minimum for x. Now, it wanted to know where are the maximums and minimums. Well, remember from the previous that we are including the endpoints of -5 and 5 for t to -5 to 5. So I need to check the endpoints, and I can see that when I plug in -5, x equals 26. When I plug in +5, x also equals 26. So those are actually going to be the absolute maximums. I have a relative minimum when when t equals 0, x equals 1. That also happens to be the absolute minimum. So what about dy dt? Well, dy dt, or I'm sorry, what about y? Well, dy dt equals 2, so there is no relative minimum or maximum because there's no critical value there. I can check the endpoints though. Y of -5 is -10, so that's going to be the absolute minimum, and y of 5 is +10, so that's going to be the absolute maximum. Remember, for absolutes, we don't need to use derivative speak. On what interval is x decreasing and on what interval is x increasing? Well, x is decreasing from -5 to 0, and the reason why is since x prime of t is less than 0 on -5 to 0. X is increasing on 0 to 5 since x prime of t is greater than 0 on 0 to 5. Over what interval is y decreasing or increasing? Well, since y prime of t is greater than 0 on -5 to 5, it's increasing the entire time. Okay, next, what could you do in the last example to reverse the direction of the path? I want you to pause the video, think about this. I'm pausing when you're ready to check. Okay, so what I did was I just made the y term negative. So x equals t squared plus 1, okay, great, and y equals -2t. That is one way in which we could reverse the direction of the path. There may be others. So if you did something else and it works, that's fine. Okay, so converting from parametric to rectangular, we know that. Now we're looking at that calculus still applies here, so we can find a dy dt, we can find dx dt, we can find dy dx. A lot of fun. Any questions? Okay, I thought, by the end of the year, maybe you guys would start to speak up a little more. Yes, I guess not. It's just me, my recorder.